Good morning dear students. Hope you all are fine and doing well in your studies. So we have already started with our third chapter of geography, that is latitudes and longitudes, and till now we have learned so many things about this chapter. So first of all we learned the meaning of latitudes. After that we learned the 5 important parallels of latitudes, that is equator, Tropic of Cancer, Tropic of Capricorn, Arctic Circle and then Antarctic Circle. After that I explained about 3 heat zones of the world. So these 3 heat zones are torrid zone, temperate zone and the frigid zone. And after that we started with our longitudes. First of all I explained you the meaning of longitude, and then I told you about the longitude and why we need longitude on our globe. Then we learned how to locate places with the help of latitudes and longitudes. And after that I told here in my next video, I told about how to calculate time with the help of longitude. In my previous video I told and in between I told about the grid system also. The grid system that is made by latitudes and longitudes. So in my previous video I told about the standard time and the local time. Okay, so now in this video we are just going to learn about the time zones. So what is time zones and why the whole world is divided into time zones? So this all we will discuss today in our today's video. So as we know that there are total 360 meridians. How many meridians are there? 360 meridians. The whole globe is divided into 360 meridians. And these 360 meridians, it takes 24 hours to complete its one rotation on its axis. 24 hours to complete its one rotation on its axis. So we can say that 360 meridians take 24 hours to complete its one rotation. Then how much time would be taken by the one meridian? So that we have already calculated when we were calculating the time, and now I am just going to write it simply that one meridian will take 4 minutes to complete its rotation. Okay, so now if one meridian is taking 4 minutes, then how many meridians will complete the rotation in 1 hour? So when 360 meridians completing the rotation in 24 hours, then in 1 hour, how many meridians will complete the rotation? In 1 hour, we can say 360 divided by 24, and the answer is 15 meridians. So these 15 meridians will complete their rotation in 1 hour, and this whole world, it is divided into 24 time zones. So it is divided into 24 time zones, and each time zone is having 50 meridians, and each time zone contains 50 meridians. Okay. So here in the world there are total 24 time zones, and one time zone is equal to 1 hour. Okay, after every 1 hour we are having 50 meridians. So this way we can say there are 24 time zones according to the 24 hours. Okay, so the next important topic is about the international date line. The international date line. International date line. So this international date line, just like the other line, this international date line is also an imaginary line, imaginary and arbitrary line that runs on the globe. And like the other meridians, this line is also, it runs from the North Pole to the South Pole. Okay, so this international date line runs from the North Pole to South Pole, and this is our Western Hemisphere, and this side is our Eastern Hemisphere on the international date line. Eastern Hemisphere. Okay, so if a person, or we can say when we cross this line, the date and the time changes. Okay, when we cross this line, the date and the day change. If you cross it traveling from the Western Hemisphere towards the Eastern Hemisphere. Okay, I said traveling from Western Hemisphere towards the Eastern Hemisphere, the date goes behind. Okay, it decreases. The date is decreases. The days goes behind by 1 and the date decreases. But if we travel from the Eastern Hemisphere towards the Western Hemisphere, in that case the days goes forward. Okay, the days goes forward and the day increases. The date increases. Okay, so this is the reason that in the Western countries they are having their New Year before, in advance from the Eastern countries. So this is our international date line, and the time, the day and the date changes from here. If we move from Eastern Hemisphere towards the Western Hemisphere, the day increases and the date also increases by 1. But when we move from Western Hemisphere to Eastern Hemisphere of this international day line, when we cross this international day line, here the day and date decreases. Suppose here in the Eastern Hemisphere, it is 11th of August. Okay, but when we cross this line and we go to Western Hemisphere, here the date will be 12th August. Okay, it will be 1 day ahead. I think it is clear to everybody. To understand it well, let us watch this video.
Time zones?
'Cause we have different watches.
Nah. Our Earth rotates on its own axis. Due to this rotation, different parts of the Earth receive different amounts of sunlight, thus causing morning, noon, evening, and night. Now, if we had one time zone, then 12 p.m. would be noon at some places, but it would be night or evening at other places, which would be inconvenient. Hence, scientists made different time zones according to the Earth's rotation with respect to the Sun.
But how?
The Earth makes one full 360-degree rotation in 24 hours. This means in 1 hour, the Earth moves by 15 degrees. Using this information, scientists divided the planet into 24 sections or time zones. Each section or region was about 15 degrees wide and had a specific standard time. This helped us know the proper time of the day in that part of the Earth.
Hold on, guys. Can you guess the title of my next video?
So, let's watch one more video which would help you to know more about the time zones.
In the old days, each town would keep their own times, with a town clock being set to noon when the sun reached its highest point in the sky. However, by the late 19th century, rail had begun to move people across great distances. Schedules became very confusing, as each stop was based on a different town's time. Thus, a need emerged to standardise time so rail could operate more efficiently. In 1884, delegates from 26 countries met in Washington, D.C. to agree on a prime meridian as a common 0 point for longitude. The result was Greenwich, England, being selected as the international standard for 0 degrees longitude and established the 24 time zones. Today, most countries follow the hourly deviations, though they do not always align with longitudes for reasons such as keeping the entire country in one time zone or altering times at certain times of the year, for example, daylight savings time. Time zones are based on the fact that the Earth moves 15 degrees longitude each hour. Since there are 24 hours in a day, there are 24 standard time zones. Time zones are counted from the prime meridian, which is 0 degrees longitude. Each time zone is counted at 15-degree intervals and extends 7.5 degrees either side of a central meridian. The international date line is an imaginary line lying 180 degrees in the line of longitude, on the opposite side of the Earth to the prime meridian. This line separates one calendar day from another. The international date line deviates in places to avoid crossing any land. In 1994, Kiribati shifted the date line 2,000 miles east to keep the entire country in the eastern hemisphere. In 2011, Samoa and Tokelau skipped a day and moved westward to be in the eastern hemisphere so they could have the same date as Australia and New Zealand, their main trading partners.
So this is enough for today, and tomorrow in my next video we will do the exercises of the chapter and we will complete our chapter. So the next video would be my last video on this topic. So thank you and have a nice day.